Good afternoon, everybody. Welcome to this poster discussion session titled HIV Reservoirs, Ups and Downs. Our first speaker is from Argentina, Hospital de Pediatría, and his name is Mateus Moragas. And he's going to give us a talk on the dynamics of HIV DNA in children over long-term sustained virus remission, impact of time of infection at viral control on reservoir size.
Good afternoon. I would like to thank the organization for the opportunity to present our work in this meeting. We all know that one of the major barriers for HIV/AIDS eradication is the persistence of the virus into the reservoirs. Moreover, the establishment of these reservoirs occurs very quickly after infection, and in addition, most of studies about HIV dynamics have been done in adult population, and there is little evidence in pediatric population. In this context, our aims were to determine the decay of viral reservoirs in perinatal infected children throughout sustained virological suppression, and to determine how the time to achieve effective viral control affects this persistence. To conduct our study, we retrospectively studied 37 perinatal infected children followed at our hospital, that is Garrahan Hospital, with at least 4 years with virological suppression. And we measured cell-associated HIV DNA and the frequency of 12-year cycles before and over 4 years of virological suppression. And both markers were performed by a modified semi-nested real-time PCR. And going to our results, and regarding our cohort characteristics, it's important to mention that most of our children didn't receive any prophylaxis. Also, they started RT later with a median age of 2.4 years. And also, they achieved virological suppression very late with a median age of 5. First of all, we modeled the dynamics of cell-associated HIV DNA in different cellular compartments and along virological suppression, using piecewise linear mixed effect model with a random slot for each child. The result of our model you can see in this figure, where the levels and estimated trajectories of total DNA are represented by dots and lines respectively. And also the shapes of dots and lines are according to the compartment analysis, which are PMCs represented by circles and continuous line, the CD40 cells represented by empty boxes and the dotted line, and finally whole blood represented by triangles and dashed lines. I'd like you to focus on the estimated trajectories of total DNA. And as you can see, the dynamics among different compartments is practically the same. In fact, there is a significant association in the level of total DNA between PBMCs and CD40 cell and whole blood. So from now on, I'll focus only on PBMCs. Going to the model, we observed a rapid decay of cell-associated DNA during the first 2 years of virological suppression, from 2.55 log copies per million of PBMC to 2.03 log copies per million of PBMC, with a decay rate of 0.26 log copies per year. And this reduction was statistically significant. However, after 2 years of virological suppression, HIV DNA remains constant. In addition, we studied what happened with the frequency of 12-year cycles, and we observed, as we observe in total DNA, that 12-year cycles frequency decays over virological suppression from 87% when children suppress plasma viral load, 37% after 2 years of virological suppression, and reached 28% after 4 years of virological suppression. And this reduction was analyzed by logistic regression, and we found that it was statistically significant. In addition, we observed that those samples with 12-year cycles positive have a higher median level of total DNA compared with those without 12-year cycles. Finally, we analyzed more deeply HIV DNA decay in this case, we stratify our cohort into 3 groups according to the age at virological suppression, where you can see children who suppressed before 1.5 years with continuous line, represented by continuous line, sorry. Children between 1.5 and 4 years in dotted line, and finally children after 4 years in dashed lines. As you can see, children with earlier virological suppression had a higher decay rate compared with those who suppressed afterwards during the first 2 years of virological suppression. Then the HIV DNA remains constant, independently the group analyzed. Here in more detail, you can see how the group of children who suppressed before 1.5 years of virological suppression have a decay rate of half log per year, whereas those who achieve virological suppression after 4 years have a 2-fold slow reduction, that is mean a 0.2 log copies per year. Finally, we can conclude that there is a markedly decay of peripheral blood HIV DNA decay during the first 2 years of virological suppression. And at this time, we observed that children who suppressed before 18 months tended to be a higher decay rate. And after the first 2 years, HIV DNA remains constant, and it was independently of the age at virological suppression. Finally, this data highlight the difficulty to eliminate the circulating reservoirs for peripheral blood, reinforcing the clinical benefit of very early effective therapy in perinatal infected children. I'd like to thank our support and our partners, and thank you for your attention.
Any questions? Okay, I'll start with one. Your pre-treatment viral load, have you looked at how that may have affected? Sorry, pre-treatment viral loads, have you looked at how that affects your time to suppression, or did it have any influence at all?
Sorry, can you repeat?
A pre-treatment viral load.
Yes.
Did you look at that?
Yes.
And did you see anything in terms of time to suppression, or did that affect your outcomes in any way? Sorry.
Our cohort is characteristic a very late virological suppression, because most of them start RT very late, and when we analyze children who start RT earlier versus RT later, we didn't find any difference, and well, we go in ahead and we analyze what happened when they achieve virological suppression, and we found that those children who start RT earlier didn't suppress viral load earlier. This is, in our cohort, this is because the adherence is very bad and the social condition of the patient is different, but we don't find any difference. I don't know if I answered your question, or is it
Okay, shall we move on to the next talk?
Okay, thanks very much for the invitation to talk. I'd like to say that this is really the brainchild of Hiroyu Hatano, who got this project started and was able to do a massive collaborative effort. In fact, I think about half the audience right now probably contributed in some way to this paper, so in this talk. So thank you very much, everybody, for making this possible. We'll try it this way. So the impact of extremely early ART initiation on HIV persistence is relatively poorly understood. As a result, we developed a program screening high-risk individuals in PrEP programs in San Francisco for acute infection. And we were really looking for those that were starting ART during the very early PHEBIG stage 1 of disease. This is what Hiroyu would call hyperacute infection. In other words, folks that were presenting that had rapid antibody antigen combination tests that were negative, but also had viral loads that were just barely detectable. So really within the first day or two of PHEBIG stage 1, really on the cusp of the eclipse to the early stage of infection. So really the earliest time point that we can definitively know if an individual is infected with HIV. After we identified such individuals, we performed longitudinal sampling of colorectal, lymph node tissues, bone marrow, cerebral spinal fluid, plasma, large numbers of PBMCs, leukapheresis several times, and also a murine viral outgrowth assay in these individuals. I didn't do it all myself, just so you know. So this is participant A. They started PrEP, what we presume is approximately 10 days after infection. So their HIV plasma RNA was 220 copies per ml. I should mention that fourth generation ELISA rapid HIV antibody test, antibody antigen combination tests were all negative at the time. And the patient converted rapidly to a 4-drug regimen, was receiving Truvada before, once the viral load resulted several days later. I'm going to show you a graph of some of the sampling that we performed and in collaboration with our collaborators. As you can see on the line, this is a plasma viral load in black. So there was a peak of 220 copies down with rapid decay. There was a little bit of a detectable HIV RNA in total CD4 T cells just as the individual was suppressing on ART. However, when we looked at the rectal tissue, we also looked at leukapheresis very early on within 2 months of starting therapy, looking at sorted CD4 T cells, tilde with Nicolas' group, and then 6 months after starting therapy with a large volume viral outgrowth assay, inducible virus recovery, single plasma copy assay, ddPCR for DNA LTR circles, looked at bone marrow that was sorted for various T cell subsets and precursors, cerebral spinal fluid sampling about a year out, another inguinal lymph node, ileum and rectum. So you get the idea. This patient actually went through an amazing amount of extensive sampling. We suggest over actually 1 billion CD4 T cells were surveyed from various tissues. Should mention that we also did a murine viral outgrowth assay. This was in Joel Blankston's lab at Hopkins. And what they do is they take CD4 T cells from the patient and graft them xenograft into NSG mice and then let them incubate in vivo to see if any HIV will come out. And 10 mice were run, 500 million CD4 T cells in total, 50 million CD4 T cells per mouse. One mouse did have low-level detectable RNA of approximately 200 copies, but unfortunately sequencing was attempted, but we were not able to get sequences, so we really could not verify this result if this was true or not. Now, in contrast, we have another participant. This patient actually started 12 days, so just 2 days after the initial participant B. And the plasma viral load at initial presentation and PrEP was 359 copies, so extremely low still, so way before it's starting to come up. Again, all the other antibody and antibody antigen tests were negative. This patient, however, did have a few days where they came off of PrEP before they started 4-drug ART, so the viral load did rose to 3,000 copies approximately 9 days after starting PrEP, actually developed an N184 mutation as well during that time, but then subsequently rapidly suppressed, as you can see here, to undetectable plasma viral load. But unlike participant A, that was just a few days earlier, we had intermittent. Now, you notice the sampling was essentially the same, so this extensive sampling was also done for this participant. But really, we're able to detect very low levels of predominantly RNA at 8, 9 months or so, and also 3 months from various CD4 T cell subsets through this patient. Their humanized mouth assay as well. Now 3 out of the 8 mice were positive at 1,000, 5,000, 11,000 copies. So this would be considered really a true positive that we would suggest is probably real at this point as well. Whole genome sequencing, rectum, and the QVA were negative. Now, because of this, we were very curious to know if participant A had any chance of developing a permanent or a very long-term HIV-free remission. So this individual underwent an ATI, treatment interruption, after 34 months of continuous ART. So had been on ART for 34 months before stopping. And for the first 224 days, you can see with either twice weekly or once weekly viral load monitoring, CD4 counts were stable. We were not able to detect any HIV RNA in the plasma. We also had intermittent sampling of cells for DNA as well, and those were also negative. But unfortunately, at day 224, viral load rapidly increased from several thousand all the way up to 70,000 or so within several days, so very, very quick, almost like acute infection. Promptly went back on ART and resuppressed. And I should mention that this actually was only 4 days off from the time that it took Boston participant B, or Gary Steinkohl, to rebound during our prior trial. So that was an interesting, although anecdotal. So we looked at sequencing with Mary Kearney and others. And if you look on the left, I'm paralyzed for these tiny little dots, but blue is acute infection. This is from plasma right when there was about 200 copies. That was the peak that we got. And then red is POL single genome sequencing after viral rebound. You can see that they're essentially identical. It was one clone and it was identical before and after rebound. So we think that the early ART really restricted HIV diversity, which I think is fairly obvious. What's interesting, we saw the envelope sequencing, we actually saw 2 clones emerge, but we didn't have any envelope sequences before initiation of ART, so we cannot compare. And the last thing I want to mention is that we collaborate with Alison Hill, who does a wonderful mathematical modeling of HIV reservoirs, and we predict that approximately 95% probability that the reservoir is less than 0.005 to 0.002 infectious units per million prior to the treatment interruption. And that's if you count that mouse model as positive or negative, if that makes any sense. We modeled it both ways just to cover our bases. But either way, the latent reservoir size is approximately 200 cells in the entire body capable of harboring replication or that harbor replication HIV prior to the treatment interruption. And using this mathematical modeling, we can also predict that approximately 1% of individuals with a similar HIV burden may achieve lifelong ART-free remission, but we did not see it here. So to summarize, HIV relapse despite initiation of ART at one of the earliest possible stages of identifying infection, really between the eclipse and early stage of Phe-big1. There was a near or total complete loss of detectable HIV in blood and multiple tissues, but this did not lead to an indefinite ART-free HIV remission. And finally, very small numbers of infected cells, so restricting that reservoir very early to just a few hundred cells may actually allow prolonged ART-free remission, if not permanent, on the scale of months or more. And with that, I'd like to thank all of the funding sources as well, and especially AMFAR and DARE for supporting the network that made this all happen. So.
Questions for Tim?
Yes.
Okay. Tim, thank you. Fantastic talk. While this patient was off therapy, and after, were you tracking any of the immune responses?
Absolutely.
To see if there was
Yes.
going on? Could you say a little bit about what was going on over time?
Yes. We have been looking at immune responses, activation markers, and various other immune response. We've been looking at tetramer responses, looking at intracellular staining. And we do see a little bit of activation happen before we see rebound on the surface of certain lymphocyte subsets. Yeah.
Okay, first of all, I wanted to comment on the timing to rebound. The 4 days different from the Boston patient is amazing, and I think that might tell us something about the timing of reactivation of latently infected cells, although, you know, like, as you said, I mean, we have an N of 2, but anyway, but hopefully future studies will learn something about that. But I also wanted to comment on the SGS. So in the acute infection and then at rebound, the viruses matched, and you said they were almost identical, but in fact they're identical because those single nucleotide changes that you see there are actually below or at the error rate of the assay.
Absolutely.
So for single genome sequencing, the RT
Yeah.
error rate and Sarah Palmer knows, of course, about this because she and I published that together what the error rate is, so those should not be considered different. And then in the rebound where you looked at envelope, we know that envelope, there's a huge selection pressure on envelope, and it selects for changes very quickly, and it's possible that those two different variants could have emerged during the rebound, that there could have been selection that quickly with CTLs or something to,
I totally agree.
select for.
Yeah.
So maybe we can look into that further and see see which is likely the case.
Yeah, and if we have some pre-sample left too, maybe we can try to
There
get
is some left. I don't know if I send it back to you or if, or if
still,
I have it,
still
but it's in a freezer
searching.
somewhere. So we need to do that.
Yeah, so we can look for that. Yeah.
Okay, last question. No? Yeah,
That was great to see that. Thanks for presenting. I just wanted to ask you if you've got any other information pre the rebound other than viral reservoirs and viral loads that could have predicted, because one of our problems, of course, is that we measure these things, it all looks great and it looks persistently undetectable, and then literally within days it comes back. Did you look at immune markers?
We did, yes. We have identified some potential candidates that may predict rebound that may not be typical what we normally look for. I can't give more information right now, but yes, so we have been looking for that. For example, we did see an increase in CD69 expression on some of the CD8 and CD4 T cells, as well as NK cell subsets before, actually several months before viral rebound. So we saw that kind of an increasing what looks to be an activation state before virus rebounded. But we've been looking at other markers as well, too. Yeah.
I have, sorry, go on.
One question. First of all, great paper. But I was going to ask you two questions. One, where you go next? In other words, obviously we're in pediatrics, we're doing some of the same things. If this is the ultimate you can do and the earliest you can get, what are you going to add to it? And a second question related to this interruption of treatment interruption is the reservoir. When you treat it again, what was the size of the reservoir? Was it? Yeah.
Right. So great questions. I'll try to be brief in the response. It's different. It's interesting. There may be a difference actually between hyperacute treatment, treating within that very early phase. I should mention that the antibody response, there was one P55 band intermediate that developed a week or two after PrEP initiation, but that disappeared. There was no HIV-specific T cell responses that we saw or were able to measure. What's interesting is that if you treat people a little bit later in acute infection, you may actually increase the post-treatment control type of cohort, where maybe you need a little bit of more immune response to be primed during that initial stage. But I don't know, and I think we need to think about acute infection not just as one group, but as a continuum where you have very early restriction of reservoir seeding but no HIV-specific immune response, whereas maybe you have less restricted seeding but more of an immune response. So again, I think we have to think of it as these are not the same cohort. They're very different between FEBIG 1 or even late FEBIG 1 and later stages of FEBIG. And I'm sorry, I can't remember this. Oh yeah, reservoir size, right? So obviously we're still in we just achieved viral decay right now, but there is detectable HIV DNA and RNA in the cells, and on the order of hundreds or so copies per million cell, which is what we'd expect in this kind of acute infection at that time point.
Thank you very much for this very good presentation. So we will move to the next presentation from Cécile Laïri. She is assistant professor at the Division of Infectious Disease at Emory University, and she will tell us about HIV RNA persistence in rectal tissue despite rapid virologic suppression in blood plasma with dolutegravir combination antiretroviral therapy in naive patients.
Bonjour et merci. So despite plasma virologic suppression with combination antiretroviral therapy, we know that HIV persists in multiple sites of the body, including the gut. Tissue HIV viral dynamics and the relationships with ART drug concentrations, however, remain poorly understood. We conducted a longitudinal cohort study enrolling treatment-naive HIV-infected adults in Atlanta, Georgia, in the United States. These patients were enrolled into an 84-day or 12-week study where they initiated daily dolutegravir-based ART with a 2-drug NRTI backbone. The patients had blood plasma and rectal tissue biopsies obtained at day 0, which was pre-initiation of ART, as well as 3 other time points up to day 84. Half of the blood plasma and rectal tissue was obtained in the early part of the dolutegravir dosing interval, and the other half of the samples were obtained at the end of the dosing interval. Both blood and rectal tissue biopsies were analyzed for quantitative HIV RNA using the Abbott real-time PCR, as well as quantitative dolutegravir concentrations using high-performance liquid chromatography, tandem mass spectroscopy, with assays validated for each anatomic site. The participants were grouped into those that had undetectable rectal HIV RNA at any time point throughout the study versus those who had persistent detectable rectal HIV. Median dolutegravir concentrations in both blood plasma and rectal tissue were compared between these two groups using Mann-Whitney non-parametric tests. 8 patients were enrolled into the study. Half were female, 75% were Black. The median age was 39 years. Median baseline CD4 was 208, and the baseline viral load ranged from 2 to 6 log copies per ml. We had 30 paired plasma and rectal tissue samples available for HIV RNA analysis. The graph to the left shows viral dynamics in the blood plasma for these participants. As we expect, all of them had a rapid decline in their plasma viral loads and all became undetectable by day 42. In contrast, the graph to the right presents viral dynamics in the same participants, but in rectal tissue. The majority had persistent detectable rectal HIV RNA throughout the 84-day study, but 3 participants did have undetectable rectal HIV RNA at a single time point. It's important to note, however, that one of these 3 did have rebound detectable rectal HIV at day 84, although they remained virologically suppressed in the plasma at that time. We had 22 paired plasma and rectal tissue samples available for steady-state dolutegravir analysis, where the participants had been taking daily dolutegravir for at least 7 consecutive days. In the group that had undetectable rectal HIV RNA, their median rectal dolutegravir concentrations were 2 times higher than the group that had persistent detectable HIV RNA, and this difference was statistically significant. There was a trend toward higher blood dolutegravir concentrations in the undetectable versus detectable group, but this was not statistically significant, and there were no other significant differences between these 2 groups with respect to demographic or other clinical characteristics, including baseline CD4, baseline viral load, time since HIV diagnosis, or the choice of NRTI backbone. In summary, we see that HIV RNA persisted in rectal tissue for the majority of our participants in the first 84 days of dolutegravir-based ART. However, those that did have undetectable rectal HIV RNA at any time point had higher median tissue dolutegravir concentrations than those with persistent detectable rectal HIV. In conclusion, ART pharmacometrics likely does play some role in tissue HIV viral dynamics. Further studies are needed, however, to determine what the implications are regarding transmission or barriers to elimination of the tissue HIV reservoir. I'd like to thank my research group and supporters, as well as all of our funding sources, and you for your attention.
Thank you very much. Any questions? I have a question regarding the HIV RNA PCR. Did you perform a specific RNA extraction before DNS pretreatment? Because if you perform this technique in rectal tissue, you can amplify also some HIV DNA. So
no, yes, we performed the RNA extraction before.
Okay.
Yes.
So specific RNA,
specifically,
like
yes.
RNA extraction.
Okay, I just want to make a comment. So ART doesn't affect the transcription of proviruses. So we know that in a chronic infection, probably 80–90% of all proviruses are latent, meaning they're not actively transcribing at all. But when you go on ART, that fraction doesn't change. And so if you're not detecting HIV RNA in the periphery, something's wrong. Maybe it's that you just don't have enough affected cells in your sample to see that 10 or 20% that are actively transcribing. And in the gut, maybe there are more infected cells, so you're just able to detect that. Also, when you process cells from the gut, there are incubations, collagenase treatments and things, there are incubations that activate latent proviruses. And so if you do those same collagenase treatments on PBMCs, you'll see that you've activated a lot of proviruses that were not active if you just collect the PBMCs and do those samples directly. So I don't think it has to do with the dolutegravir or the treatment. I think it may just be sampling that you're seeing this difference.
For your comment.
Oh, a question? Okay.
Did you say if you use single-cell suspensions or
It was frozen tissue.
Thank you very much. So we can move to the next presentation.